What's going on YouTube? This is IPSEC, and we're going to do something a bit different today. I didn't prepare that much for this video. Hacking LZ sent me an article from Palo Alto's Unit 42 of them talking about some APT 29 phishing tactics of them using the brute Ratel C4 framework. And I found it hilarious, not because they're just using a paid C2 tool, but the fact how APT 29 can be so successful for so long using the same techniques, but just swapping out the tool. So we're going to go start off by looking at a bunch of news articles showing them do it in 2016 with a zip and shortcut, but using a custom implant. Then they hacked some more people in 2018 using a zip and a shortcut, but this time using Cobalt Strike. And here we are in 2022, them doing a ISO, which is essentially a zip and a shortcut, but this time pairing it up with brute Ratel. So they're pretty much doing the same exact phishing campaign, just keep swapping out the tools and are successful. So I found that pretty funny, and then took it as a good time to go into reversing malware, how to extract it from memory, and some basic things of just what to look for. So with that being said, let's just jump in. Before we get into anything too technical, I wanted to talk about the motivation behind this video because I found it interesting / funny. It comes from this blog post by Unit 42 from Palo Alto Networks talking about APT 29's use of the brute Ratel tool. Now, this whole blog post is great. I would highly recommend reading it. But the piece I found hilarious is right up in the beginning. It's the executive summary, right? That talks about APT 29 and their campaign, how it's attributed. How it worked is, it seems like it's a phishing document that they crafted using brute Ratel, or actually, they took brute Ratel's shellcode and injected it into their normal technique, which is how a lot of red teams would operate. Their technique that they use for phishing is sending this ISO file that inside the ISO file has a Windows shortcut, a malicious DLL, and a legitimate copy of Microsoft OneDrive Updater. So before we get into exactly why they do this, which is pretty obvious in hindsight, I want to show why it's funny. Like if we just Google APT 29 LNK ISO phishing, we go to this Mandiant post, the Not So Cozy, which I think talks about something in 2018, and it's near the same thing. Let's see, is it up in this thing? Let's see, zip. So yeah, it's using a LNK file in a zip. That is the main difference here. So if we look at LNK, I just want to go up one. Similarities between this attack in 2018 and a different one back in 2016, both which used the same, let's see, new elements, as well as the deliberate use of old phishing tactics, techniques, and procedures, including the same system to weaponize Windows shortcuts, LNK files. So I couldn't find exactly this post. I'm sure it's out there that says how it's packaged, but they've been doing this type of phishing for what, since 2016? So like 6 years using these LNK files. And if you want to know how to like exploit an LNK file or create these, if you go to ipsec.rocks and type like shortcut, we have creating malicious shortcuts via PowerShell. We're examining one right here. So there's plenty of information out there to do that. So the reason why they're doing all of this is because of something called Smart Screen in Windows. So when you open an when you download an executable, it puts some metadata in that executable as part of a ADS, I think, alternate data stream. It's just metadata that tells Windows this file came from the internet. Now, when it downloads a zip file, which includes ISOs, it can't go inside that ISO and tag all those files with the ADS stream saying it came from the internet. So if you give someone an executable in an email, they download, they click on it, it may ask for administrative privileges or may warn them that this shouldn't be executed. But if you put it inside of a zip or an ISO, they click that, it opens a little pretty Explorer window, and then they click your executable and it runs. So it's a way around Windows Smart Screen. Alternatively, you could just buy an SSL certificate and sign it, which would also help bypass AVs, but the easiest way is just these ISO files, and obviously it's less attributable. Now, the other piece, they have a payload DLL and a legitimate copy of Microsoft OneDrive Updater. So what they're doing here is called DLL Side Loading. So they're taking a normal binary and putting a DLL next to it. So when the binary opens, it looks like at its current working directory, pulls from that DLL and executes it. Now, what this is getting around is in like sysmon or something like that, if you see a program being ran, you're just going to see Microsoft OneDrive Updater. Its hash is going to be the same because you may not see the DLL it's loading, because if you track all those DLLs, it's going to be a huge like performance decrease. So also, it's assigned Microsoft binary, which may bypass some firewall rules. There's just a lot of good things that come from, I guess, maybe this is bring your own land. I don't know, just reusing binaries that are normal on a system and doing this side loading. If you want to know more about that, go to my YouTube channel, look for the DLL injection video, because those two techniques are very similar. So if we scroll down some more, there's a lot of good information about this. But the next thing I wanted to show you is kind of what it looks like. This is just one. I think it's just working off a shortcut, which is how that one back in 2018 also worked, I believe. It was a PowerShell shortcut that would download a file, then execute it. But in this one, we see what it looks like. And I'm guessing all this stuff is just in order to hide, right? Because we see these are kind of grayed out. So these are all hidden. And the shortcut, because it's in an ISO, I think you can just give it a custom icon. So if someone clicks on the attachment, opens it up, they may just see the word icon and it's a CV, so it's like a resume. They may not notice it says shortcut here, it's 4KB, so they'll open this, which then probably triggers this OneDrive updater.exe to run, which then loads version.dll, and all the bad things happen, right? I'm guessing it will also pop open a legitimate copy of a resume. As if we went back to that 2018 blog post, I know it showed that. And we can see here the shortcut, it is running cmd.exe/c start OneDrive update, and it talks about it. So lnk to the exe to OneDrive to DLL to something else to it now running. So with all of that context, now let's go create a malicious executable using something. We could just go straight into the reversing piece, but generally when you get malware, you're going to get it packaged in something. So I want to highlight exactly how you can extract that from an executable, because I just don't see a lot of people posting that online. And there's going to be a lot of ways to do it, but this is generally the very first thing I would do. Okay, so I switched over to Linux just because it's easier to create the next step. I just have shellcode that is generated by the C2 program. Almost any C2 program will give you the ability to get shellcode, whether it's Cobalt Strike, Brute Ratel, Nighthawk probably does it. I'm sure Outflank does as well, because the shellcode itself is the heart of the program. You generally, or it's up to like the red team to create their own programs that load the shellcode, because the program is going to be able to obfuscate and evade antivirus, right? They load it, the shellcode, or execute the shellcode in a way that AV won't be able to see it. And the whole benefit to doing this is it's very modular. Like the first time I created an implant, I had manually created a service executable, a DLL, and an EXE. And whenever I made a change to my agent, I was like, oh crap, I have to update it in 3 different places. So if instead you write it in a way that you can compile it to a shellcode or use Donut or SRDI techniques to convert whatever you make into shellcode, then when you create just a service template, you can then embed the shellcode in that service template and you have a service. You can create a obfuscated DLL loader and then just embed the shellcode in that and you're good. That's essentially what MSFVenom is. So we're going to cat the shellcode and we're going to pipe it over to MSFVenom. And then I'm going to say the payload comes from standard in. In Linux, whenever you do a hyphen as an argument, that means standard in, and this is sending it from there, right? The next thing we want is to say it's an EXE. We want to say it's 64-bit, and we want to tell it the platform is Windows. And of course, the output file is going to be please subscribe.exe, right? So now we're loading it from standard in. It's going to hopefully create this payload. There we go. I'm going to do an IP-ADDR, Python 3-M, HTTP server, so we can stand this up and copy it over to a Windows machine because we can't just execute this. So have the web server up. I'm going to switch over to Windows 10, and then we can go 192.168.230 and download please subscribe.exe. So this should be in my downloads. It is. And if I just ran it, it probably would send a shell somewhere, right? It's an executable that's going to execute shellcode. We want to extract the actual application out of this, right? So I'm going to do x64 debug, and we're going to open C: users ipsec downloads please subscribe.exe. So we have this now. If we just run it, it's going to go to the first breakpoint, which is the starting point. Most of the time when you run one of these droppers, it's going to do some type of process injection to get it out of its current running state. Generally, we'll inject into like a web browser, explorer.exe, things like that. A good way to catch that is, let's see, we want to go to, where is it? I'm going to run it so we hit the breakpoint. And then if I go to symbols, we can go to ntdll and we can set breakpoints on any function, right? This is a good one I normally start with, this LoadDll breakpoint. And right now, if I look in the memory map, we just broke at main, right? So let's look at protections. Let's see what there is, if anything stands out. I don't think so. Let's see, type. I know it's a private commit. Maybe this one. This is read write. I think it's going to be this one we want to look at. If we follow it and dump, we can see nothing's here yet. Memory map 1000. If you're not following me, don't worry. So I'm just going to run it because we have the breakpoint at the LoadDll. And when we run it, we're going to hit that. We see it's calling it. And then we can go back into the memory map and kind of examine what's going on. Look at the protection. We see this one is really weird. It started out execute read. The permissions in this is really odd. You would expect execute to be X because that's what it is in every other tool. But in xdebug, E is for execute. So it's execute read. But initially, it was read write. So it started out read write. And this is not 1000, this is 1700. But it started out read write, and now it's execute read. So it's never execute read write or read write execute. It starts out read write, then loads data in, eventually goes to execute read. And now if we follow this dump, we can see it starts out with nothing, right? But then we have a PE. This is indication that there's data here. Looking at this is strings. This looks like an executable, right? So we want to dump this thing to a file. The whole reason why I'm guessing the actual header is missing, let's go back here. This is also weird. Being a private commit with an execute, if it's not .NET or things that have CLR, this is going to be really weird behavior. We know it's not .NET yet because it's missing a lot of things. If we open up in Process Explorer, you wouldn't see any of the, I'm forgetting, the app domains and things like that. So it being private commit execute is also weird. But if we look at it, it starts out with null bytes. This should probably be MZ, the strings. And the whole reason it probably does that is because if an antivirus hooks on this LoadDll call and then goes into the memory map and sees MZ as the very first 2 bytes, it's going to raise a suspicion, right? So the creator just nulled those out. So if AV looks at that and doesn't examine the whole bits or only examines the first few bytes, it doesn't move on and say, oh, this is an executable he's executing. So it's just a weird obfuscation technique. Probably should have nulled out a bit more of the whole PE structure, but just doing the E magic field, I think is what it called, is fine. I mean, it works. So I'm going to dump this to a file. I'm just going to go to my desktop, and then we're going to start analyzing it. And we're going to add the MZ back in. So we got please subscribe.bin. I'm going to copy this and we're going to go back over to Linux because that's where I have IDA installed. So here we are. The file is just on my desktop. You can see it right there. And right now, if we look at it, so if I just do xxd desktop, please subscribe less, we can see everything is nulled out, or at least the eMagic field is, where it would say MZ. So if I run it in IDA, I don't know if I had a paid version. I know Ghidra also doesn't like it because it doesn't have the magic bytes to know exactly how to parse it, right? So if I just open this file, let's do new, open this, and it's going to say it only disassembles PE files. So what I'm going to do is just open the hex editor, so hexedit the file. I'm going to hit tab and then just type MZ here to put the header there, Control S to save it, then do yes, and then Control X to exit. I think that's nano like hotkeys or whatever. But now if I look at it, we have MZ as the first 2 bytes of that, and then the PE header and everything else is still down there, so it can be completely parsed, hopefully. So let's do IDA 64, and we can disassemble this file, and I'm going to say I'm not a reverse engineer by any means, so this is all just self-taught type things or things I picked up from talking to people. So may say wrong things here, but hopefully what I say helps you and doesn't like confuse people more, point people down the wrong path. So we have this. It's a huge file. The very first thing I generally start off with is looking at the exports. And we can see just TLS callback, the entry point, and then ordinal 1. So the very first thing, it's just got a function at ordinal 1 that it probably calls. If you don't know, this is probably just to evade strings. So if you go to my YouTube channel with like building a undetected version of Mimikatz, we changed some of the calls to use ordinal loading, which is essentially just saying, go to this DLL and load this function at this number. So if this was like the string we were loading was please subscribe, and it was the 3rd function in a DLL, it would be at ordinal 3. So instead of saying use please subscribe from the DLL, you could just say use the 3rd function from the DLL. So if we look at this, press F5 to decompile it, we can see what it's doing. And a lot of this, how do I make this bigger? Let's see, options, font. Let's change this to 20. That seems good. It's probably too big. Oh well, we'll live. So the decompiled output is a bunch of gibberish. The one thing this is doing is calling functions by their ROR13 hash, and this is just something I guess you pick up by experience. We can right-click, convert it to hexadecimal, and then if we search the internet for this string, this is just telling us it's 64-bit, but let's go to Firefox. If it opens, come on Firefox. Go to Google. If we search it for this, we get to Stephen Feuer's reflective DLL injection, and where he defines things. So this is the hash for load library A. So it's very much like the ordinal loading. It's just a way you can call it. So this is load library A. We could look at the next one, and this function itself is going to be a reflective DLL thing to load things. So this is get proc address. So we could name things and go down the list. I'm not going to do it for this whole function because we saw it was pretty big. But the main thing I just want this piece of the video to go over is just how this ROR13 loading works. The next thing I would generally do, which in this current version, I'm not sure about the latest version, but there's a pretty big opsec fail, and that there's a lot of strings in this binary. So we're going to go over that, why I think it exists. It probably doesn't exist on the latest version. I don't have that because I don't have the software to just pull the latest version and look at it. But I think it is a good talking point. So let's see. We want to go view, open subviews, strings. Now there's going to be something we can do. I don't think it's default. I think it's set because I've used IDA before, but I think by default it's just set at C style, not 16-bit. But we don't have a whole lot of strings yet. We'll get to that in a minute. But there is one string that catches my eye, or the very first string that caught my eye in this binary was coffee. It strikes my mind because generally this is either going to be a reference to Mimikatz, because Mimikatz has a coffee function that just is to test Mimikatz to see if it works. The second is it's a coff loader. So it's like a way to just execute shellcode. Cobalt Strike has BOF files, BOF, and all that is really a coff file. It's a common object file, but it has a beacon header in it, so you can do some custom things with the implant, pull strings, things like that. So coff is very similar to BOF if you use Cobalt Strike. We can go in here. Let's go to this function, go to the decompiled output, and we can see where it's calling it. So I don't know exactly what this function is. We can go down. It's doing %ls plus. Let's see. This is saying invalid arc, and these strings are weird. Let's see, is this used anywhere else? So this sub 61FA, I could probably just click and do X. We look here, it says it's a call to ls. We can go and I pressed X on the function. You can see how often this thing is used. And we see account lockout policy, password length. So right now, I'm going to just call this printf to teamserver, because this looks like output an operator would want, right? So just renaming that, we can go back to this and examine it. And going through, like, my main thing was, is this going to be Mimikatz? Looking through it and see any other of those strings. I'm going to guess this is some type of coff loader, right? So I'm going to rename it to that. So in this function's name, we have it. And generally, the first thing I would do is see any more of those ROR13 hashes in it and declare their names. I don't know exactly what that is. The other thing we could look at is a public sample of what a coff loader is, right? So if I do coff loader trustedSec, as I think they are the first ones to post anything, like post source code about this. We can look at it. Let's see. Coffloader.c. I'm near the bottom of this. And one thing we see, which isn't going to be a smoking gun to anything. Where is it? Is it not in this file? Okay, right here is where I wanted to go. So we have a loop here, 0 to 25, and I see a loop here for 0 to 25. I'm not sure exactly why they loop 25 times, but looking at this code, the 25, we can compare it here. So it's going through each section and then doing a virtual free, and then a print, right? So we want to see exactly what this function is. We can, actually, I did not want to double click it. Let's go back. Oh God, where am I? Let's see, right here. I'm going to press X. And I'm going to go to where this move is. Let's see what this does. Decompiling. Okay. So I'm here. And what I'm going to do is convert this one to hex. And we're going to search this. So go back to Firefox. Do this. Put OR13 in. And we see that's in kernel 32. And that is virtual free. So we can go back into our program and call this function now. I'm just going to do roll13, virtual free. And we have that. So now it's doing a for loop, calling virtual free, and right outside the thing, it's doing virtual free as well. I would probably spend more time comparing, like analyzing exactly how this works to this, but based upon the string coffee and also like the function and exactly how it's working, I'm assuming this is a coff loader, right? Now, the other thing I wanted to get into, if we edit, let's see, let's go view, subviews, strings, and I'm going to select, let's see, setup. Let's just do every type of string, right? Let's do all those. And now we're going to get more things in this. So if we search for something like AMSI, we have AMSI and ETW patched, right? So we can then go to where it is, look at this code, and we see it talking to the team server, say AMSI patching is not required, unable to patch there. So I'm going to call this MSI Patch because we know that function name. I'm not exactly sure what that's doing. Maybe that's a, let's see, I don't know. Running .NET CLR. What is this doing? It's been a while since I actually looked into any of this. So this is, so v25, it said it's patched. Let's see. I'm going to do a search on this string. What is this string? I wish I prepared more to do this. I think this blog post came out today, right? Oh, it tells us. So this is a decryption key, right? So that's the decryption key right there, hard-coded in the program. So I don't know exactly what that function is. It's probably something decrypt. The question marks went to underscores. That's fine. Maybe decrypt. Let's see. I'm still trying to figure out exactly where the patch AMSI is. Let's see. Maybe, what is this doing? Nope. Let's see. Is this view going to help me more? So that's patching ETW. Let's see. Going, jumps to here. Calling printf. And I'm honestly not positive. I'm guessing maybe a bit I'm missing right now is when it decrypts this, maybe it's pulling something from the actual profile. I was looking for it to like load AMSI.DLL, v10, keyword v52. Maybe this pulls something like that. I don't know. But generally, when I first start looking at something, I don't spend that much time on each function. I'm just getting all the things, right? So I would go back to the subviews, go to strings, find something else that is interesting. Let's see. I think it's loading strings. What? View, subview, strings. There we go. So let's see. If we do service, this is another one to look at. We have service created, uploaded. I always like looking at service uploaded, mainly because we may get some IOCs, and it looks like we have one right here. So we upload service. I'm guessing this is, let's see. This is probably size. Let's see. What is v34? Let's just see what this function is. So I'm going to press X to view cross-references or whatever, xrefs. Go to hexadecimal. Copy this. And there's probably some like IDA script or something that automatically does all this thing for me, which would be handy. But again, I don't do this enough to where this whole process is actually optimized. This is Open SC Manager A. And now that we have this, we can see what these functions are, right? So if I Google this, go to the documents, it says machine name, database name, desired access. So we know v6 is going to be the machine name. This is going to be the desired access. We can right click it, do enum. And let's see, it's probably going to be SC Manager. It's either one of these, right? Key all access or SC Manager all access. So we're opening the ServicesActive service with all access on the remote machine. So right off the bat, I'm guessing we upload a service, we create it. I'm guessing down here there is a started. So if I had to guess, this is going to be like a start service thing. So go here, hit X. I like going to where the move is. Scroll all the way to the right. Convert to hex. Search this. Create service. So this one is create service. And I'm hitting N to rename. So this is going to be service handle or something. I'm guessing this is start service, would be my guess. So this is probably going to be some type of PSExec, just because of it creating the service, starting it. And down here, I'm guessing this is probably going to be mapping standard in, out, and error. I'm not positive. And at the end, we free everything of our memory. But this, because it's hard-coded, definitely is an IOC, because this is going to be the service name. LP database name, ServicesActive, right? So this would be something I would look in Elastic, Splunk, whatever your logging thing is, to see if you've ever had a service called ServicesActive. We can go back to the strings and see some other things before we call it a video, but hopefully this has helped you understand something about this. I don't want this to be a super long video. Maybe I'll do a stream where we analyze it more in depth if people really want that. But I'm like at my limit of what I understand right now. So can't really explain a lot. We have it monitoring user login, log off, which is interesting. Let's see, minimum password length. So if we look at this function, let's see what this looks like. So this is probably some like password check or something, because we see it says minimum password length, minimum password age. It's probably getting information out of like get password info maybe, right? Like an opsec thing, maybe upon getting a beacon or getting whatever it's called, it runs this to populate some information. Not sure exactly what it uses it for, but it is interesting nonetheless. And again, all I do is keep going down. These strings really make it handy. And why I believe these exist, and again, just my intuition, I'm guessing this program is somewhere in the middle of, or at least the version I have is somewhere in the middle of the program, moving to a fully modular functionality. Because generally when you, let's do this. Let's do this function real quick. This looks simple. Maybe it's not a simple thing. But generally whenever the team server sends a task to a server, right? I really want to get to a simple function that I can explain this with. I should have renamed that PSExec function, right? Let's see. I should just do the hotkey of Shift F12, I think it is for strings, yeah. I don't know why I keep clicking it. Let's see. If we sort it like this, what do we have? Go near the top. Home directory. Crisis monitor, DLL. And TFS. Privilege added. I think I clicked on the wrong one. I think I'm clicking one too high. I think the font size is throwing me off here. Priv. That's not the strings view. Strings, priv, added. Is this it? Nope. Everything was going so smooth until this last segment that I wanted. Enable debug privilege. Go here. Awesome. So this is enable debug, right? Okay. Let's see if we can prove that. Else. What is this function? So str copy SE-debug. Then it's copying the result from this. I bet if we go here, go to where this move is, hexadecimal, and that just changed everything. Is this one it? The one I clicked? What are you? Copy. This open process token. So if we go back, this is open process token. So if we can open the process token, then it's going to do something else. Let's see, hexadecimal. This is a very tedious process. Look up privilege values, and first it's going to check what we have. And then, let's see, what's V1? Open process. So I guess this is the one we want. Let's see. Hex. So I guess the main takeaway of this video is how to deal with ROR13 hashes. Let's see. Google helps so much. Close handle. Done. I thought I was going to get the call. It actually does it. I skipped it. Should not have skipped it. Let's see what this one is. Hex. Copy. You and this one. Adjust token privilege. There we have it. Okay. So, here we're copying SE-debug to V5. So I'm going to call it debug string. And then we open the process token. And if we can open the process token, it's going to look up the privilege of SE-debug privilege. And then if we don't have it, it is going to adjust our token privilege to enable it. And either way, if it can or not, if it can enable it or can't enable it, it's going to close the handle, right? So that's how this function works. And if we go back one more time, I think, right here, we're in this, I think, EnableDebug. I think this is the function I was in. Yep. Not exactly sure what this is doing. Looks like the same thing. Maybe it's just checking if debug is enabled. So I think after it enables, it checks if it is my guess. I didn't look at it, like, those like few seconds you saw of it was all I looked at that function, right? But, so the team server says, hey, implant, enable debug privilege. And then the implant goes, runs this code, and says, hey, I've enabled the debug privilege back to the team server. There's really no reason for the team server to really not know what it just tasked the implant to do, because it would probably send, generally how like I code the implant, at least if you look at my C2 video, I have some type of enum or structure that has task code. So I'd send it a task code of 10. When the implant sees 10, it enables the debug privilege and then reports back either success or fail, probably the Windows exits code, because if it errors out, it gives me some debug information on why it failed. And then the C2 server sees, oh, it was successful. It's task code 10. That is debug. I'm going to tell the operator debug privilege has been enabled. So the reason why I think it's in some middleware behind highly modular is the actual implant itself may only have some type of like inline execution or coff loader type thing. So you just constantly give it these common object files and it does the thing, reports back. And the whole benefit to that being will be the implant you have becomes very small, because the only function in the implant is to execute coff files. So when a reverse engineer gets it, they can't identify all the features that are in the implant, because every time you want to execute something, the C2 server sends that shellcode to execute it, right? And because you're sending so many coff files, you only like, it looks like it may only be coded with just one task, the coffee task, to execute it. So it's just saying, hey, execute this coff file, execute this coff file, execute this coff file. The implant itself, or the C2 server itself, doesn't look like it's storing what that coff file was, so it doesn't know the exact result. It's just embedded in the file. Like if you look at how Cobalt Strike is with BOFs, B-O-F, all those strings are going to be hard-coded in that, because the actual Cobalt Strike server, you don't modify that. You just send it the BOF file, the client pipes that BOF file through the team server. The team server doesn't really inspect it, goes directly to the implant, and then it's up to the implant to tell the user what it is. So it's a bit of a different way of thinking. Right now, like I think this version is in the middle grounds, which is awful because it's super easy to signature when you have all of these. And this is why I'm guessing the creator of this put so much faith in his obfuscate sleep, putting a lot of work there. So the memory of this program is always going to be encrypted, so you can't just inspect the memory. That would be my guess, because if you can just dump memory of this, it would be easily flagged. So this is an indication the obfuscate sleep is working, and if in the later versions it goes into a more modular format where the actual implant just executes coff files, so like the functionality to enable debug, not in the actual implant that's running, that's coming from the team server, then it becomes a lot harder to reverse and more forgivable that the strings are embedded, because that's how it works in a lot of the C2s. If it was really advanced, it would like have all the shellcodes or common object files, whatever you want to call them, as tasks. So when the C2 server says, hey, I'm going to send it the enable debug common object file, it's going to report back success fail. I know I sent it this object file. I'm going to put the strings around it, right? But right now the C2 supposedly is just one guy, so that's a lot of work to have all that functionality. This is certainly much, much quicker. So hopefully you guys have enjoyed this video and found it beneficial. I'm going to wrap it up here because I think I'm approaching like probably 45 minutes to an hour, and that's a long video, a lot of information to digest. Hopefully I didn't say too many wrong things. Take care, and I'll see you all next time.